Greetings and welcome, friends. Me and my algebra buddies are here. We're talking about measures of center. That's right. That if I have a data set and I wanted to represent a lot of numbers with a single number, right? Like if I had a lot of information, but I'm like, could you just give me like one number that kind of represents them all, like one number to rule them all? That's what we were talking about. And within data sets, we have measures of center as well as measures of variation. We'll talk about a little later today. But it asks this question here. It says, describe how removing an outlier from a data set affects the mean of the data set. Okay, so that's a little bit interesting. So if I have an outlier, that means it's a point that is far from the others, is kind of the general way to think about it. The example we looked at yesterday was the case in which we were looking at salaries for summer work, where most people were making like $8 or $9 an hour, and then there was suddenly a person who was making $16 an hour. That 16 was an outlier compared to the rest of the data, okay? So that's the idea of an outlier. And sometimes, in order for my measures of center to be more closely representative to the majority of the numbers, I might intentionally remove an outlier so that I can have a measure of center that reflects the majority of the data. You guys with me here? I don't know if anyone's looking yet. Also follow along on your packets and write down corrections if need be. So if I remove an outlier, what does it do to the mean? The mean was the more typically referred to average, although technically all measures of center are types of averages. But the mean was the one where I do what? How do I find the mean? How do I find? Add all the numbers. And then you divide by the number of the numbers. I like it. The quantity of the numbers. So what does it do if I have that? Now imagine if I've got like a data set like this, and I've got like a frequency, and then I've got this one outlier way over here. Maybe the original mean would have been something like this. My middle number, the median, would probably still be over here. But if I end up choosing to exclude this outlier, it will actually take the mean and move it this way. It will actually bring the mean closer to the median. So that's the answer. It brings the mean closer to the median. And as far as mean, median, and mode, we'll talk about sometimes which of those is the best measure of center because it depends on your data set. All right, here we go. Question 7. So flip ahead to that if you want. It says, find the mean, median, and mode of the data set, and then determine which measure of center best represents it. So I did skip ahead a little bit. I'm not going to do every problem, but that's how we do. So the mean is sometimes, here, you can shut that off, please. The mean is going to be the sum of these numbers, 13 plus 30 plus 16 plus 19 plus 20 plus 22 plus 25 plus 31. And then I'm going to divide by how many there are, which is, right, 1, 2, 3, 4, 5, 6, 7, 8. And when I do that, I get 176 over 8, which is 22. Are you guys able to find the mean okay? 7. Follow along now, friends. If I want to find the median, ladies and gentlemen, if I want to find the median, what do I need to do? I can't find the median with this current list. That's right. I got to put the numbers in order. Let's see. So smallest number, I've got 13. Looks like 16 is next. Thank you. 19. Yep. Like I've got 20. That's a sad looking 6 there. Let's see. 20, 22. All right. 30, 31. Okay, so now that I have the numbers in order, what do I do to find the median? Okay, what's the middle number? I actually have two numbers in the middle. One of the things that I've seen students do, and I like this, to find the middle number, they'll say, all right, let me cross one off on this side and one on that side. 2, 3, 3. And then if I try to go 4, 4, I realize, uh-oh, I don't have a middle number. So what do? I take those two middle numbers and I find their average, or the middle of those middle numbers. So I get 42 divided by 2, I get 21. Yep. And what was the mode for this data set? No mode. What does mode mean? Yeah, the most frequently occurring number. They all occurred the same number of times, right? There was no duplicates. So the mode is no mode. Well done. Well done. Now, let me actually open up my spreadsheet here. Okay, and I'm going to click on question 7 down here. All right, so here's that same data. Notice if I go down to the bottom, I've got tabs. You might have to hit these arrow buttons over to find more. On the data, at the bottom, arrow over if yours doesn't show enough of them, and find the problem labeled 590 parentheses 7. Okay, well, follow along. So if I want to find the average here, yesterday I showed you that I could use the equals average formula with an open parenthesis. You guys remember that? And I could drag that down. I could close parentheses if I'm a good doobie and hit enter, and bam, I get 22 as my average. And that's the same thing that I found here. Also, just in terms of formulas, I could have written my own average formula. I believe Ben was telling us that if I add the numbers, look at this. If I want to add the numbers together, I use the sum formula. And watch this. Let's see. There's 176. That's the sum. What else do I need to know to find the average? I need to add them together and know divide by what? The number of them. And so I can actually find the number of them. I can write equals count, open parentheses, select my data, and that's going to tell me how many of them there are. So here's the sum, here's the count, and if I want the average, watch this. This is a new trick. I can just type equals. I'm going to take this, hit divide, this. All right, you can reference multiple cells just as though they were like variables within an equation. All right, so there's 22. And one of the cool things about these formulas, let's say I'm like, you know what, let's change 13 to 14. All of these formulas will real-time update if I change a value or multiple values. Okay, so all of those formulas dynamically work because these are pointing to what would be thought of as like variables, right? They could represent multiple things. All right, which one's the best? In this case, the mean is the best, and the reason is because there were no crazy outliers. All right, if there's an outlier, some extreme value on low end or high end, then the median would be a better representation of that data. All right, let's see. Let's keep scrolling. Yes. All right, we don't have time. Yeah, that's true. That's me. That's me. Here's question 10. It says, find the mean, median, and mode of the changes in stock value. So, check this out. I'm on question 10. Let's see, Maya, to find question 10, I'm going to go back to my data sheet, go down, look for 590, question 10, and there's the same thing, the changes in stock prices. Some are positive, some are negative. That's fine. Remember, use these arrow keys if for some reason that tab is hidden from you. So let's see, if I want to find the mean, actually it won't let me do that. But I can use average formula. And watch this. I'm going to average and go down a little bit further. I'll go down to cell 14 here. I get an average of, negative 40 cents. So X bar is equal to negative 0.40, right? I want the median, let's see. So I'm going to write equals median. Now I could arrange the list in order, right? I could do all of that. Actually, let me go down one cell further. Equals median. Right, I could do that manually. I'm just showing you how it works using data. All right, so the median in this case was 80 cents, positive, an increase. Okay, or 86, my bad. Up, up, there we go. So there's the median number. Now, one of the things you can do, if I was like, man, I so wish this data was sorted. If I select my data, I could either... No, that's vertical alignment. I'm trying to remember where that is. But there is a sort column A to Z. And actually, that's funny. That actually sorted including the title. I thought, man, how am I forgetting this? I used to, what? Or if I right-click on it, data sort range. Here we go. I can also select this. I could say, oh, the data has a header row. There we go. So that way it won't include sorting the title. That's not sorted. Oh, there we go. That's all right. I don't need the header row because I already removed it. There we go. So it'll sort your list in order. Let's actually just verify that. So look at this. I'm going to copy and paste this. And let's see if I wanted to take this list and find the median. I would just look for the middle number, right? So let's cross off the list. So 1, 1, 2, 2, 3, 3, 4, 5, 5, 6, 6. Uh-oh. It was another case where there were 2 in the middle. So I would rearrange this, right? So to find the median, I would take 0.67 plus 1.05 divided by 2. That should be, is that 0.86? I'm guessing. All right. And is there a mode here? Nope. It's easy to spot a mode when that's sorted data as well, because there would be 2 numbers that are the same right next to each other, or more, right? If it could occur 3 or 4 or 5 times. So this looks like a no mode as well. So no mode. Which measure of center best represents the data? Your guys' thoughts. Turns out the mean represents the data best because there's, once again, no outliers. All right, and now question C, it says, on the 13th day, the value of the stock increases by 428. How does this additional value affect the mean, median, and mode? So $4.28. Let's watch this. So actually I'm going to watch this. So 4.28, I'm going to add 428 to the bottom of my list, and it should recalculate the mean and the median for me automatically. Okay, so notice that in this case, if I want that to have a dollar sign, I can click on give me a dollar. So here we go. So I ended up with a new mean and median, right? So here's my X bar, here's my median. You can always make a cell that's a label if you want. You could write, I could have written mean and median over here if I wanted. So that way, if I was like printing this out, someone would be able to look at it and be like, oh, that's where that crazy number's coming from. So the mean is negative 0.04, the median is 1.05. Notice it actually increased both of them. Both mean and median. Why didn't it change the mode? Or actually, I didn't... Oh, no, it will change the mode. Guys, that's crazy sauce. Yeah. Oh, man, I was going to say it wasn't going to change the mode because it wasn't a duplicate. But why am I wrong? For what reason is it going to... Oh, wait. Okay. No. I'm thinking median again. Guys, Mr. Waddy is I doubted myself, guys. Doubted myself. I was right. The mode isn't going to change. The median changed because in this case there was no middle number, right? Or there was a middle number once I added a new number to the list. That the middle number would have actually been this one here. So that's why the median changed. The mode did not change because there's no repetition. Mode is still no mode. The way it could have changed the mode, someone tell me how could it have changed the mode? Or what type of number would this have to have been in order to have changed the mode? What if it was a duplicate of any of those original numbers? Right? If instead of adding 428, what if I added 203? I would have then had 2 of the 203s. That would have been the new most frequently occurring number. And then there would have been a mode in that case. So that's how it could have ended up changing that. Let's see. I'm going to have to skip that for now. Okay. Real quick. Identify the outlier. From this list of numbers for question 16, which one's the outlier? Yeah, it looks like 46 is way bigger than the rest of them. Do you guys agree? So the outlier is 46. And how does the outlier affect the mean, median, and mode? For mean, it will increase it. It's kind of artificially pulling my average number way higher, when in reality, my average should be somewhere between 1 and 7, right? But maybe this is pulling it way higher. For the median, it's going to increase it a little. Not a lot of change. Not a lot of change. And for the mode, it's going to have no effect. What is the mode in this problem? I think I see the mode here. Does anyone have a guess? Yeah, it looks like I've got 1, 2. I've got 3 2s, and I had 2 1s. Yeah, so the mode was 2. But yeah, it didn't end up changing that. Then they ask this question. This is non-mathematical, but kind of more just to see what you're thinking. Why would this outlier have existed if this was talking about the size of emails in kilobytes? Why do you think that email was suddenly so much more massive than the others? Yeah, what type of email would have way more information than the others, do you think? One that maybe has an attachment or links built within it, right? Like maybe they attached like a picture to that one where the other ones were just short text emails, would be the explanation. So anyways, thank you for watching, mis amigos de internet. Adios.